In this video, I'm going to show you how to install Cellpose to be used with QuPath or Fiji. There are many ways to do it. I'm going to show you one that is not too difficult to do and that should work with any environment. Cellpose is coded in Python, so first we need to install an environment that let us install a Python code. To do so, we're going to install Anaconda 3. So I'm going to open a web browser and you can type in Anaconda download and you should have something for Anaconda. So if I go to the main link, alright, so here there's a link to download the distribution, and I'm using Windows and so it's already the right version, so I'm going to download it. And I'm going to speed up the downloading time so you don't have to wait for it to be done. Alright, download's over, so I can open the file. And it asks me if I want to install Anaconda, so I'm just going to go next, agree. Next, I'm going to install it in my user folder. And I'm going to install it just with the regular options. So again, I'm going to speed up the video so you don't have to wait for the entire installing time. Alright, it's down, so it's a bit misleading. It goes very fast up to almost the end and it takes a little bit of time, but that shouldn't be too long. So now I can just go next and finished, and I don't want to have a tutorial or anything. I'm just going to finish it. Now that is installed, so if you type in the launching bar Anaconda, you should have something which is called Anaconda prompt, Anaconda 3. So we're going to open this prompt and we're going to install Cellpose from there. So first of all, we need to decide where we're going to install Cellpose. So as with anything in Python you're going to install on your computer, if you ever do so, something which is extremely important to remember is that you should always, first of all, define a virtual environment. The great thing with virtual environment is that when you have defined a virtual environment and you have activated it, then you can install whatever you want in this virtual environment and it will stay forever as long as your computer runs, even though, you know, there are new distributions for the packages you're using, the old distribution will always work because it will never change. And so that's extremely powerful and that's very important. And so you should never install something on your base system. So here you can see, you can read base. This is my normal environment, and you should never install anything on this. You should first of all always define a new virtual environment or activate an existing one. There are several ways to define virtual environment. Here we're going to use the virtual environment valve, V-E-N-V. So first thing, I'm going to create a virtual environment and I'm going to create in the directory I'm in. So here, for example, I'm in users tpcut. If I want to install it somewhere else, I need to go to that place. So let me show you. For example, you want to change drive. So here I'm in the C. If you want to change drive, you need to first launch a command. So let's say I want to go on the D drive. I need to do D dash like this. Now I'm on the D drive. So that's a bit different from the DOS. You can directly use the CD command with the DOS, but it seems that with Anaconda prompt you need to change your drive like this. If I want to go back to C, I can do it that way. So let's say I want to go on the D. I'm going to open an Explorer And let's say I want to define a virtual environment in my work directory. So one easy way to get the path in Windows is to use the Shift. So I'm pushing the Shift button, and now I'm doing a right click. When you do that, you have something which is called copier en tant que chemin d'accès in French, which should be copy as path in English. When you click on that, now you copied the path to this folder. So if I go back to my prompt, it's in the D drive, so I'm going to do D dash like this, and now I can write in CD for current directory and define the directory I want to go there. So that's the one I copy with copy as path. If I do Ctrl V, I have the path to this folder. So if I do enter now, as you can see, this shows you where you are. I'm in D work, and I'm going to create my virtual environment here. So to create the virtual environment with the venv way, I'm going to type in Python -m venv, and then the name of my virtual environment. So I'm going to call it Cellpose for a Cellpose environment, and I'm going to push Enter key, and now it's creating my virtual environment. Just take a little bit of time. Now it's down. If I go to my directory, if I go in work, I should have this folder which is called Cellpose environment, and that's where I'm going to install everything. I still need to activate this environment. I'm still in my base environment. To activate it, I'm going to go inside that folder. I can show you to activate it. You need to go to Scripts and launch Activate. So this is possible directly here. I'm going to do /script, and you can use the tab command, so it's going to autocomplete. So it's not script. I forgot, it's not directly script. I need to go in Cellpose off. So first Cellpose and / and you see the autocompletion is nice, because you know that when you autocomplete it, it's the right tapping. For example, if I do a small s and c, then if I do tab, it's going to do the big S. So scripts, and I say then activate, and now I have activated my virtual environment, and I know it because here I can see Cellpose off. And so now, finally, I can install Cellpose with the pipe command. And it's fairly easy. You just type in pipe install Cellpose, and now it's going to install everything that's needed for Cellpose. So you should have other folder here. It's because I already installed it with another environment, so it doesn't have to download the files. They're already there. In a normal environment, you would see some colors that are displayed and downloading time, but that would work the exact same way. And then now it's installing. So I'm going to speed up video so you don't have to wait. Alright, that's over. Cellpose is installed. So you can look at here, you have many different commands that were installed. We don't need to care about it. What's important is that Cellpose is actually installed. I'm going to close this folder. I'm going to keep this because I'll need that later on. And I'm going to open QuPath. All right. So to use Cellpose in QuPath, we need first to install the Cellpose extension. So I'm going to go back to my browser here. Not the right command. Google. All right, let's go there. And I'm gonna type in Cellpose extension QuPath. And then you get this GitHub page. So it's been developed by BIOP, which is an imaging core at the EPFL. If you go there, so you have all the codes. What is important is to get the latest release. So here they show you how to use it, how to install it, and you have some scripts. I'm not going to go through this. I'm just going to go to the releases. So here you have the releases. If you go to the latest one, you have an extension Cellpose, which is a zip code. So I'm going to download this. All right. I'm going to go to my download folder, and I'm just going to put it on my desktop. And here I'm going to unzip it. And so in this folder you have two files. One that is a Python file. It's if you want to actually do some retraining of your Cellpose models, define a new model, or just training within QuPath. It's great, but that's not what we want to do today. We just want to install the QuPath extension. So you have this jar file, and you can just drag and drop it into QuPath. And then it just says that you now have the extension for the BIOP Cellpose extension for QuPath. If you want, you can check it in install extensions here. And I can see that I have BIOP Cellpose extension with version 0.6.1. Second thing we need to do is to actually tell QuPath where the Cellpose installation is. This extension allows, so it makes a bridge between QuPath and Cellpose, but we still need to tell QuPath where the Cellpose installation is. So if you go to Edit, Preferences, now you have something which is called Cellpose. And so you need to first of all define which environment you used. So I told you we used the VENV, the Python Valve virtual environment. So we're going to use that. And then we need to define where is the virtual environment. So if I go back to dwork, that's my virtual environment. So I'm going to do, again, Shift, right click, copy as path. And I can go back here, copy it. The only thing you need to do is to remove the quotes. Alright, and then you can just close it. If I go back to it, I can check that that's the right environment. So I'm going to close it. And now I'm going to open a QuPath project. In blue, I have a marker that allows me to identify two-way fibers. So these are muscle fibers. So blue tells me where the 2A type fibers are. In green, I have the 2B types. In red, I have the 1. And in white, I have a laminin, which stains the basal membranes that surrounds muscle fibers. So if I only look at the last marker, the laminin, it's great because I can see where all the muscle fibers are, and I can use QuPath, and I can use Cellpose to segment these fibers. So I'm going to define a small annotation, and then I'm going to use a script to run Cellpose. So you can actually go to if we go back to the QuPath extension Cellpose, you have some scripts. You can also use a script that I defined. So if I go to git add tpcut, here that's my GitHub page, and there's so that's training I give for QuPath with some materials, and in the scripts, there's one script to actually segment muscle fiber with Cellpose. So I can just copy and paste. If I go back to QuPath, I'm going to open the script editor, show script editor, and I'm going to just paste my my script. So here I'm using the Cyto2 model. So these are the different parameters. Mainly this is a pixel size, the channel I'm going to use. So here that's channel 3, because you need to remember that you start at 0. So 0 for 2A, 1 for 2B, 3 for 1, and 2 for 1, and 3 for laminin. So that's the correct channel. The normalization, the probability for the presence of cells, which here are not cells. Actually, we're using Cellpose for muscle fibers. Just to remember that this is not between 0 and 1, but it's between -8 and something like 16. Flow threshold, so these are parameters associated with Cellpose, but diameter here I know that I need to increase a little bit. This is if you want to do some expansion. Here we just want to segment the fibers, we don't need to do expansions. Get the measurement associated with shape and intensity, and then I can run it. So if you are running it for the first time, it might not work. I'm going to check because I already installed with other versions. It might work. Let's see if I do run. So here it's launching everything, and here, so yeah, you see it's actually downloading the models. I'm gonna see if I can kill it. I'm gonna show you how to do it, because most probably, so here it's working because I already installed Cellpose before, and it knows how to download the pre-trained models. We're using Cyto2, which is a pre-trained model. It means that Cellpose needs to download, so through Python, this model, so then we can use it to segment our muscle fibers. The first time you're going to use it, it's very much likely that this won't work, and it's just going to stop because the model is not downloaded. However, what you can do, as it says here, execute command that tell you this command should run directly if copy-paste into your shell. So what I'm going to do is that I'm going to copy, so not this, I'm going to start here with Python and everything else. And as you can see, the way it works is that it defines tiles from this area, and then each tile is processed with Cellpose. So if I copy this and paste it directly in my prompt, it's going to work. And so if it didn't work in your QuPath environment, if you do that directly in your Anaconda prompt, then it's going to start by downloading the model. And so that's really, really useful, because if you do it for the first time and if it doesn't work, that's the only thing you need to do. And then as the pre-trained model will be downloaded, then you will only have, you won't have to do anything. It will work directly in QuPath. So it should, alright, so we didn't see it, but the thing is that it downloaded the models, and now we have two tiles. So it processed the first one, it processed the second one. So it's working. So when the model is downloaded, you can just shut it down. So I'm going to do a Ctrl+C. And now I'm going to call it from QuPath again. So if I run this script, that should work. So you see now we go directly here, and it's processing the first, you see 0/2, because we have two tiles were created from this annotation. And we'll check it because when we're going to run Fiji, we're going to we're going to go directly in the temporary folder where the tiles are, and we're going to run it from there. Now it's processing the second time, so it's a bit long because we didn't implement the GPU version. So if you want to do that, I'll show you in another video how to do it. Just gonna wait. So it's down, so it took 30 seconds to do the first time. It's probably gonna take about the same time. Yeah, now it's down. It's getting back the mask, and now it's down, as you can see, so I can close the script. I could segment my fibers, and that worked pretty well. So that's a great way to actually segment fibers, even though they are not cells. So this is how to do it with QuPath. I'm going to show you how to do it with Fiji now. So I'm going to reduce everything. I can close this now. And I'm gonna start my Fiji. So to run Cellpose with Fiji, you can actually install a plugin that's been designed by the same authors that did the Cellpose extension for QuPath. So it's already installed, and I'm gonna show you where it is. So if you do help update, which is the right way to install plugins with Fiji, actually, at least when it's possible. So everything is up to date. If I go to Manage Update Sites, here I can add new plugins, and I'm going to show you which plugin is actually used. It's the PTBIOP. So BIOP, I told you, is an imaging called EPFL, and so their plugin is called PTBIOP. So it's already installed. If you want to do it with your Fiji version, you just click PTBIOP, close the window, then you're going to have a bunch of files. You can just apply changes, restart Fiji, and then when you go to plugins, you have something which is called BIOP, and as you can see here, there's something which is called Cellpose. So I'm going to open my Explorer. I told you within QuPath, the way it works is that you tile the annotation that is defined, and then you run for each tile. So if I go to my, actually I can directly go in this project. So that's the project I open with QuPath. And you have something, you should have a folder which is called Cellpose temp. That's where the tiles are defined, and that's where the masks also are. So the output, that's the output of Cellpose that was run from QuPath. And just to show you that we can do it with Fiji, I'm going to open this image, which is one of the tiles. So just to reassure you, you don't create a temporary file for each annotation, so it would explode. So actually the plugin, how it's designed is that it's gonna always use this temporary folder and put all the tiles in this temporary folder, and when you run it again, it's gonna remove everything in this temporary folder and then define new tiles and run them. So it's possible that if you do it for whole slides, this might get a little large, and you know, when your analysis is done, you can just remove this folder because it's not needed anymore. So here, just to show you that we can use the plugin within Fiji, first thing we need to do, as for the QuPath Cellpose extension, we need to, if you go to Cellpose, we need to define where Cellpose was installed. So it's similar here. You can define the environment, so you have less option. You only have VENV or Conda. So as I told you, we used the VENV way to do it. You can then define the location of your virtual environment. So it was in the work Cellpose of. You need to define the version. So I didn't explicitly defined the version when I installed Cellpose within Python, but that's the last one, so it's 2.0. I'm gonna do OK. And so now it knows where Cellpose is installed. I can directly run Cellpose. If I go to Cellpose Advanced, I have more or less the same parameters. So here it's going to be 100 for the size. I'm going to keep, so this, for example, 0.4, same as before. I'm going to use the Cyto2 model. The channel, so we don't have any nuclei channel, it can be 0. The Cyto is this channel, it's 1. So here it starts at 1, not at 0. And then I can run it. And so it's going to take the same amount of time. It took 30 seconds, so it should take about 30 seconds to run it, and then get the masks, and then I have my result within Fiji. So that's useful because here you can define macros to run Cellpose, for example, if you want to automate this. So I get this. If I use, for example, I can use class B and dark, so different color. Something that is also useful within the same plugin, you can go to BIOP image analysis, and you can do label. So this is a label image because we have a different intensity for each object. I can do label image to rise, and then it defines a rise for each image. And so, for example, I can now visualize with different results. So as you can see here, it would be nice to do some filtering to remove the small objects, so something that you can easily do with MorphoLibJ, for example.